All right, Math 5130. I've kind of struggled with how to proceed after the first kind of the intro videos on correlation and regression. And it's always a goal of mine to try to teach the material in as few videos as possible and to create videos as short and brief as possible. So in the spirit of that, I think what I want to do in this video is demonstrate to you in StatCrunch and R how we run a linear regression model, a simple linear regression model in this case, and how we interpret the results from the outputs, because it can be a little complicated. It can be a little bit confusing. So and I will tell you, I'm a huge R fan. This is one case situation where I prefer StatCrunch over R, but I'm going to demonstrate just how to run a model. So in R, I'm going to demonstrate it first and then kind of bounce the idea off StatCrunch. And you can see I've got this data set. It's called SLR model, which you have. And let me back up here. The goal is going to be to predict BMI from weight. And so the first thing I would do is I would run the model, and I use the LM command. And the LM command always has the Y goes first, so I'm trying to predict BMI, which is my Y, and I'm predicting it from weight. So again, let me come out here and use a hashtag so I can communicate to you. The form is always, and if you get this backwards, you know what happens. It's always LM Y tilde X. So in this case, we are predicting, whatever we're predicting is always Y. So BMI is our Y and weight is our X, so this should make sense. And yep, unfortunately, if you get that backwards, you get all the wrong answers. Okay, so the next thing I do is I do summary model, and I get a lot of stuff. Now, let's just go through this line by line, and you're going to want to really take good notes here and write all this down for your, to help you on assignments and help you on everything, right? So first thing it does is calls the formula, predicting BMI from weight. The next thing it does is it gives us descriptives of the residuals. Now, we talked about the residuals in one of the previous videos. Remember, residuals play an important role. It's just the observed Y minus the predicted Y. So if we created all the residuals, the minimum residual was negative 8.14. The max is 12.6. The median and the first quartile and third quartile are given. The next thing we get into is we get into our coefficient table. And in the simple linear regression world where we have one predictor, we will have the information for that predictor on this line. This line up here is the intercept. So the first thing that I pull out of that information is that my model y hat is equal to, and again, this number sign, this hashtag just says I'm communicating to you. I don't want R to perform anything. I just want to communicate to you. All right. So 4.32 plus 0.30 times the weight. So really our y hat is our predicted BMI. So our model is 4.32. We get that from this first line right under estimate. Now, the standard error is used in calculating the t-value. I don't go into that much, but I like to present the standard errors in my table, which I'll demonstrate either in the next video or the video after. Because you want your videos of your, I'm sorry, you want your standard errors of your predictors, once we get into multiple predictors where we have multiple lines, to be stable. So in a simple linear regression world, it doesn't mean much. The next thing we get is our test statistic. And our test statistic, the one that interests us most, we don't really care much about the intercept, at least I never do. And you'll find out that it is almost always statistically significant. Nevertheless, we report it. But the tunnel vision is on the line of the predictor. In this case, our predictor is weight. Our test statistic is 31.75, and we have statistical significance at the 0.001 level. So we would report that, and again, I'll teach you how to report this stuff a little later. Now, the residual standard error, okay, is just information on the error that we have in our model. I don't want to get too much into this at this level, but something I do want you to see is that our degrees of freedom are 298, and that would be the corresponding degrees of freedom for this test statistic. And again, that'll become a little clearer when we see all this written up and summarized. The next thing we get into is the multiple R squared. And this is extremely important because this works as our effect size. But more importantly, it tells us something important about the percentage of variance that in our dependent variable that's explained by our model. So we could say here that 77.2% of the variation in our y is explained by the regression on weight. So in general, 77.2% of the variation in y is explained by the regression on x. Now, this is something I think most students, when they see it the first time, it makes no sense to them. But again, we're trying to explain how much variation in BMI can we explain by having the measurement of weight on the patient, the subject. And this is just a fancy way, a technical, a correct way of stating that. So multiple R squared is extremely important to be able to report and to understand.